NC State has close to 40,000 students. And all these students generate a lot of waste on campus. Part of that waste is food waste. And have you ever wondered what happens to the food waste after it's generated on campus? Well, today we're going to take a tour of the NC State Compost Facility and Research Cooperative and talk about how we manage that food waste and turn it into a usable product called compost. We started operation at the compost facility in July of 2019. We're a large Type 3 compost facility in the state of North Carolina, which means that we can compost pre- and post-consumer food waste, manures, dairies, meats, and anything other than biosolids. Every week, our trucks service up to 40 compost dumpsters that are around campus. Most of those dumpsters are dedicated to food waste, but also pizza boxes, paper towels, and also greenhouse waste that's generated on campus. The way I like to define composting is managed aerobic decomposition. Keyword there being aerobic decomposition, because we're dependent on aerobic microbiology to decompose all the organic feedstocks that we add to our compost mix. And just like any other living and breathing thing, this microbiology requires certain chemical and physical requirements to do that job. They require a carbon source, a nitrogen source, an oxygen source, and we've got to provide a means for aeration, and we've also got to provide water so our compost house can maintain a consistent moisture content throughout the process. So step one in the composting process is we have a truck 2 times a week pull up to our receiving bay and then push out of the back what's mostly food waste that's contained in green compostable bags. Also coming along with that food waste are paper towels, pizza boxes, and greenhouse residuals. Now that food waste that comes in every week is our main nitrogen source for our compost mix. We also have animal bedding that's delivered twice a week from the vet school, and that animal bedding is mostly wood shavings with a little bit of manure, and then we also have wood chips that are delivered from around town. And this animal bedding and those wood chips are our main carbon sources in our feedstock mix. Once we've collected all our feedstocks, the first step in our process is to mix them all together. So we're trying to control a few different variables in this mixing process. First, we're trying to achieve a 30-to-1 carbon to nitrogen ratio. Second, we're trying to achieve 50% moisture content in our compost mix. And lastly, we want a bulk density of around 900 to 1,000 pounds per cubic yard of this mix. After we load up our mixer, we'll let everything churn in there for around 15 or 20 minutes. And during that time, all those green compostable bags are being ripped open, its contents are being spread out in the mixer, all the moisture that we've added to the system is being evenly dispersed, and what we want is a nice homogeneous compost mix that's ready to start the composting process. So after mixing, we'll open the back door, turn on a conveyor belt, and we'll start pushing that material off into the next bay. While that's happening, I'll pull in and out with the loader, and then with that loader, I'll start loading up our composting bins. Our early stage of composting is done using an aerated static pile system. And what that means is we actually force oxygen into our compost piles during the early stages of decomposition, because this is when the biology has its highest need for that oxygen, its highest demand. And the way we achieve that is each of our composting bins is equipped with an air compressor and a trunk line that goes down into the floor, and those trunk lines in the floor push up oxygen, push up air into our pile, which aerates our piles without us having to move them, without us having to turn them or manipulate them in any way. Now, during the time that our compost mix is in the bin, we need to achieve certain time and temperature requirements in order to make sure that we can eliminate any pathogens that might have been included in our feedstock mix, and also terminate any weed seeds that might have come in with our wood chips or our animal bedding. This process usually takes around 24 to 28 days. So after about a month, we'll open up the doors to our bins, and then we'll move that material out into the field, in which it enters a second stage of composting, and eventually it starts to cure. This is around a 90 to 120 day process. While our pile starts to cool, the biology starts to settle down, and we've got more of a finished product. We build windrows in the field in order to maintain aerobic conditions and just encourage airflow throughout the piles. After around 120 days, we've got a final product, and our next step is we screen that final product to make sure we get out any bulky materials like wood chips, or even contamination that's made its way through the process that would be littering the final product, but also making it more difficult to spread. We use a 3/8 inch screen, and so our final product is about a 3/8 inch material, which makes it widely adaptable for different uses around campus and out at the Lake Wheeler Road Field Lab. Contamination is something that we've got to manage at our facility day in and day out. And contamination in our waste stream are things like plastic, glass, or metal that finds its way into either our compost dumpsters or a waste receptacle on campus and makes its way out to the compost facility. Managing contamination comes at a huge opportunity cost for us at the facility because we have to dedicate a certain number of hours every week, and usually a little more, just to hand pull out all of those contaminants so they don't stay and don't make it into the final product. So this is the time where I like to encourage any student, faculty, or staffs that might be watching this to please be mindful of where you're depositing your organic waste and any waste you throw away so you don't contaminate any waste stream coming from campus. Our compost is used broadly in and around campus, used for different projects, building projects, planting projects, also out of the Lake Wheeler Road Field Lab. And by using compost on campus, or using compost, applying it to the soil or in any environment, you're taking that all that beneficial aerobic biology that we built into our compost, and you're inoculating the soils on campus. And in doing that, a whole host of benefits comes to follow. It enables nutrient cycling in the soils, it increases water holding capacity and water infiltration, and will suppress disease in the soils. It also is a stable form of carbon that's being put back into the soil where it belongs. If you're interested in learning more about compost and its broader impacts on the environment and society, feel free to reach out to one of us at the Waste Reduction Office. We're happy to give you more information. Also, if you'd like to come volunteer at the compost facility, we're always happy to host volunteers. We'll give you a tour around the facility, talk to you more about how composting works, and that's another great way that you can learn about composting, its impacts, and how you can do your part on campus to make sure that we can continue to promote a sustainable environment and a sustainable place.